Section 3.4, Adding and Subtracting Polynomials. When solving equations, there were times that we needed to simplify a side by combining like terms. Here's an example. We've already done this type of problem. If I have 3x plus 4x plus 2 equal to 5x plus 7 plus 3, the very first thing to do in order to solve that is to combine any like terms. 3x plus 4x is equal to 7x, so on the left-hand side I have 7x plus 2. 7 plus 3 are constants on the right-hand side, so on the right-hand side I have 5x plus 10. If I wanted to continue to solve this, I could go through and subtract 5x from both sides. I'm going to get 2x plus 2 is equal to 10, and then I'm going to subtract 2 from both sides. I'm going to get 2x is equal to 8, so x is equal to 4. So we've done some things where we had to go through and we had to combine like terms. We are going to do the same thing in section 3.4, but we are also going to be doing it with parentheses. Here's an example of one that is inside a set of parentheses. And as long as I am adding, which is what I'm doing right here, I'm adding, there really isn't anything different. I can just go through and I can rewrite this, and I can just get rid of the parentheses because I'm adding everything that's in here. So it's plus 5d squared. It is still subtract 6d because it's a minus 6d in the parentheses, subtract 9. And now I could go through and look for my like terms like we have done and put them together. I have a 4d squared plus 5d squared. Remember, the operation that's in front of this term tells you what I'm doing with it. So 4d squared plus 5d squared is 9d squared. I have a 8d, but it is a negative 8d. Subtract another 6d, which gives me minus 14d. And then I have a constant plus 7, subtract 9, which gives me minus 2, or a negative 2 as I go through it. And that's the answer to that. Really nothing different than what we were doing before. There are parentheses there, and as I said, I am adding between those sets of parentheses. I do want to mention that some students, rather than writing it that way, like to write it up and down. And I'm going to do that as well. You won't see me do that a lot, but some students like to line things up that particular way, and you can certainly go through and do it this way if you want to, lining things up. Now I have my d squareds lined up. 4d squared plus 5d squared is 9d squared. A negative 8d plus a negative 6d gives me minus 14d, and a plus 7 plus a negative 9 gives me minus 2. So some students do like to write it up and down. I generally will not do that. I think it's easier just to kind of go through and look for the like terms, but you might find this helpful, and if you do find it helpful, please make sure you go through and do whatever way works best for you. Here's another example. As I take a look at this example, I see that I have a 4x squared y plus a 5x cubed y. Remember that I cannot put those two together. They are not like terms. I have to have exactly the same variables with the exponents in order to say that they are the same. Those are not the same. They are not like terms. There's nothing at all I can do with that. I also have a subtract 3xy squared and a subtract 2xy. Once again, there's nothing at all that I can do with that because those are not like terms. So make sure that as you are doing this section that you only add together or subtract things that are exactly like terms. The answer to this is there's nothing you could do. You would just leave it that way, or you could get rid of the parentheses. It would be exactly the same thing if you just got rid of the parentheses, and you would just leave it like that. There's nothing at all that you can do to combine. Perhaps the number one mistake I see in all of algebra is when students have to subtract polynomials with parentheses. Please be careful and double check your work whenever you are subtracting with parentheses. Let me show you what I mean. If you are given the problem 8 plus 3 inside a set of parentheses, subtract 6 plus 3 inside another set of parentheses, all we have there is constants. So I could go through and solve that by just following the rules of please excuse my dear Aunt Sally. Do it in parentheses first. So if I did that, I would get 11 subtract 9. I would get a final answer of 2. Sometimes, though, I cannot do it that way, so we need to talk about doing this another way. If I wanted to, I could change this problem and get rid of the parentheses first. So I'm going to rewrite what I have. I have 8 plus 3. This subtraction sign tells me I need to subtract everything that's inside the set of parentheses. So I need to subtract the 6, and I also need to subtract the 3. Now, if I do the math, 8 plus 3 is 11. 11 minus 6 gives me 5. 5 minus 3 also gives me 2 for an answer. I get the same answer both ways. But because there was a subtraction in front of the parentheses, I had to subtract everything that was inside the set of parentheses. And this is the area where a lot of people tend to struggle. So let's look at another similar problem. This time I'm going to have 8 plus 3 subtract 6 minus 3 inside that second set of parentheses. Once again, I could do that by following the rules for please excuse my dear Aunt Sally. I have 11 subtract 6 minus 3 is 3. I get 11 minus 3 is equal to 8. If I do it by removing the parentheses, I'm going to have to get exactly the same answer. So I would remove the parentheses for the first one, 8 plus 3, subtract. This tells me to subtract the 6, so I'm going to subtract the 6. This also tells me to subtract a 3. Subtract actually means to add. So I actually changed that operation inside the set of parentheses. I changed it to addition. Now if I go through and solve this, 8 plus 3 gives me 11. 11 minus 6 gives me 5. And 5 plus 3 once again gives me an answer of 8, which is the same answer I got when I did it the first time. Here's an example of a problem with variables that I cannot do by using the please excuse my dear Aunt Sally rules because I can't combine anything that's inside the set parentheses. So the very first thing I need to do is I need to go through and get rid of the parentheses. So I'm going to rewrite this without parentheses. The very first one just stays the same, 3xy subtract 4y. This subtraction sign tells me that I need to subtract 7x, and the subtraction sign tells me I need to subtract 2y, which means I need to add 2y. Now I'm going to go through and combine anything that I can combine. I have a 3x subtract 7x, which is a negative 4x. I have a negative 4y plus 2y, which means I have minus 2y. So the final answer to this problem is a negative 4x subtract 2y. In your homework, you will see some problems that look like this. Subtract 5x plus 1 from 7x plus 8. And the very first thing you're going to need to do is you're going to need to just rewrite this in numbers. And they want you to subtract this amount from this amount. So I'm going to have to rewrite, and I'm going to be rewriting it this way. 7x plus 8 minus 5x plus 1, with both of these being in parentheses. It said to subtract this from the 7x plus 8, from this. So it needs to be written in that way. Now I'm going to go through and I am going to get rid of the parentheses. So I'm going to rewrite what I have, 7x plus 8. I need to subtract 5x. I also need to subtract 1. And now I can go through and combine my like terms. 7x minus 5x is 2x. And then 8 minus 1 is 7. so I get a final answer of 2x plus 7. Here's one that's a little bit longer and a little bit more involved. And once again, the very first thing I need to do is I need to get rid of my parentheses. So the very first one, I can just write down what I have, 4x to the third plus x minus 3x squared. But now I'm going to subtract, and I need to subtract a 4x. I need to subtract, which means I'm going to add a 2x squared. And I'm going to subtract that positive 4x to the third, which means minus 4x to the third. I want you to notice one thing when you do the subtraction. When I go through and do that, notice that the first number stayed exactly the same. The number in the second one stayed exactly the same, but the operation sign switched from subtraction to addition, and the same thing for the third one, the operation sign changed from addition to subtraction. And that's something that will always work for all of these. Now I'm going to go through and I'm going to combine my like terms. I have a 4x to the third, subtract 4x to the third. Those are just going to cancel each other out. I have a plus x and I have a subtract 4x. That's going to give me a negative 3x. And then I have a negative 3x squared plus 2x squared, which is going to give me a negative x squared. And that is the answer to that problem. Now, one thing, you would probably not see the answer written that way in the book. Instead, they normally put the terms in order based upon the exponent. You would probably see this written in the book, negative x squared subtract 3x, which is exactly the same thing. I would take either one for an answer. I just want you to recognize that both of these are exactly the same answer. There's one more example in this section to talk about, and you can see it on the screen here. Notice that this is different because I actually have a negative sign outside the first set of parentheses. You can think about that as a negative 1 times everything that's on the inside, and once again, that is going to change those signs. If I think about that as a negative 1 times a negative 7, I actually get 7x. If I think about that as a negative 1 times a negative 4, I actually get plus 4y. So I get 7x plus 4y when I get rid of those parentheses. I'm going to continue, subtract 2x, and then subtract 3y, and then I'm going to combine what I have. I have a 7x subtract 2x, which gives me a 5x. I have a 4y minus 3y, which gives me minus 1y. Of course, you would see that in the book just as 5x subtract y. As I mentioned before, the number one mistake I see in algebra is when subtracting polynomials with parentheses. If you have any questions after looking at this, or if I can help in any way, just let me know.